These are the solutions to the quiz questions at the end of lesson 2.3. Now, number 1, we have which is the unit for capacitance, and it's the farad, so that's A. Question 2, we have which of the following changes would result in an increase in the energy stored if all other things stayed constant, and we could increase the distance or decrease it or increase the area. But if we've got energy stored in a capacitor and then we do any of these things, none of them can actually give the capacitor more energy or take it away, and so the answer is D, that none of these changes will actually change the energy. Now, question 3. A battery charges capacitor A until it reaches a potential difference V, and a second identical capacitor is charged until it reaches a potential difference of 2V. How does the stored energy compare? Now, we've got the energy is a half CV squared. So if V is doubled, that means the energy must be times 4. And so that is answer D. Now, question 4. We've got a capacitor. It is storing 4.3 microcoulombs of charge, which is 4.3 by 10 to the minus 6 coulombs. We know the voltage is 1.5 volts. So capacitance is just Q over V, 4.3 by 10 to the minus 6 over 1.5, and that gives us 2.9 by 10 to the minus 6 farads, or 2.9 microfarads. Now, question 5, we have a voltage of 280 volts. We have a capacitance of 850 millifarads, which is 850 by 10 to the minus 3 farads. And we want to know the energy. It is a half CV squared. So we've got a half times 850 by 10 to the minus 3 times 280 squared, and that will be 33 kilojoules, or if you wanted to write it, you could say 3.3 by 10 to the 4 joules. Now, question 6, we have an energy of 73 joules, and we have a capacitance of 120 millifarads, which is 120 by 10 to the minus 3 farads. Again, energy equals a half CV squared. So our 73 joules is a half times 120 by 10 to the minus 3 times V squared. So V squared then is 73 over half times 120 by 10 to the minus 3, and that equals 1216.7. Take the square root of that to get V is 34.9 volts, or to two significant figures, 35 volts. And then question 7, we have a parallel plate capacitor with a capacitance of 7 millifarads when it's filled with a dielectric. So the area is 1.5 square meters. Separation is 1 by 10 to the minus 5 meters. So the capacitance without the dielectric will be E naught times A over D, which is 8.854 by 10 to the minus 12 times 1.5 over 1 by 10 to the minus 5, and that is 1.33 by 10 to the minus 6 farads, or 1.33 microfarads. So the capacitance being 7 millifarads, means that we have kappa is the capacitance over what it would be without the dielectric there, with just air, and that is 7 by 10 to the minus 3 over 1.33 by 10 to the minus 6, which gives us 5.3 by 10 cubed, or 5,300.